Hello, Algebra Scholars. This is section 7.2 on Systems and Substitution. We have a four-step algorithm that you can see right here that we're going to follow, and let's talk through it as we solve this example that I've written out for you here. So step 1 says solve either equation for x or for y. It really doesn't matter, but the easiest thing to do is pick a variable that has a leading coefficient of 1. Those are the easiest ones to solve for. So I'm going to actually solve for y in the first equation. So the first equation is y minus 2x equals negative 6. And to solve for y, I just have to add 2x to both sides. I get y equals 2x minus 6. So that's step 1. Step 2 says substitute that value, and by that value I mean what y is equal to. It's equal to 2x plus 6 into the other equation. So that's going to go into the other equation in place of y, because 2x minus 6 is what y is equal to. So this second equation, instead of writing 2y, I'm going to write 2 times 2x minus 6 minus x equals 5. Notice I've replaced y here with 2x minus 6 here. It's what y is equal to. Step 3 says solve this new equation for the remaining variable. So we'll distribute 4x minus 12 minus x equals 5. We'll combine some like terms. Add 12 to both sides, and we will get x equals 17/3. That is step 3. Step 4 says take your answer from part 3, right here, and substitute it into the equation from step 1. Well, here's the equation from step 1, and we're going to put this number in place of x. So y equals, instead of x, I will write 17/3. So 2x and then minus 6. So 2 times 17/3 is 34/3. I need a common denominator, so that'll be 18/3. And 34 minus 18 is 16/3. And that is how you solve a system using substitution. Okay, here's a second example to solve using the method of substitution. Remember what our steps said. First step was to solve either equation for either variable, and we said to look for a coefficient of 1 if we could find it, and I see one here. So x minus 3y equals negative 1. All I have to do is add 3y to both sides. So x is equal to 3 minus 1. I'm going to substitute that value now into the other equation. So that's going to go in place of x. 5y minus 2 times the quantity of 3 minus 1 equals 4. 5y minus 6y, distribute the negative, be careful, this is now plus 2. And combine some like terms. This is negative y plus 2 equals 4. Subtract 2 and divide by negative 1. And then the easiest place to go is right back to our very first equation. And we can say x equals 3 times y minus 1, or negative 6 minus 1, or negative 7. So the solution is negative 7 comma negative 2. Here's a third example solving systems and substitutions. It's a word problem. It says the difference between two numbers is 2. 3 times the larger plus 1/2 the smaller is 34. What are the numbers? Alright, so let's define our variables as larger and smaller. And it doesn't matter what you call them. I'll let the larger be x and the smaller be y. So here's what we know. The difference between them is 2. It means if you subtract them, you get a difference of 2. But when you subtract, if you get a positive difference, you have to do larger minus smaller. And then we know that 3 times the larger, well, that's 3x, plus 1/2 of the smaller is equal to 34. And now we'll solve this system using substitution. I will solve the first equation for x, and I will do so by adding y to both sides. And then I will substitute this value in for x in the second equation. So 3 times y plus 2 plus 1/2 y equals 34. Let's distribute 3y plus 6 plus 1/2 y equals 34. Oh, let's clear the fractions. No one wants to work with fractions. So 6y plus 12 plus y equals 68. 7y plus 12 is 68. And 7y is 56, which means that y must be 8. Let's go right back here, and x is then 8 plus 2, which means that x is 10. And we can check our answers. Is the difference between these two numbers 2? It sure is. And is 3 times the larger, 3 times 10, plus 1/2 of the smaller equal to 34? It sure is. So we know we found the solution. That's it.